Did you know the Earth has a giant, invisible force field protecting us? It's our magnetic field, and it's essential for life as we know it. But here's the twist. This shield isn't stable. Throughout our planet's history, it has weakened, shifted, and even completely flipped. North has become south, and south has become north. This is called a magnetic reversal, and scientists say we might be heading for another one. What does this mean for us, for our technology, for life itself? Let's dive into the fascinating, and slightly alarming, world of Earth's magnetic field reversals. So, what exactly is this magnetic field? Deep within our planet, a churning ocean of molten iron and nickel, called the outer core, acts like a massive dynamo. The movement of this superheated liquid metal generates powerful electrical currents, which in turn create the magnetic field that envelops our globe. This field extends thousands of kilometers into space, forming a protective bubble called the magnetosphere. It's our planet's first line of defense against a constant barrage of charged particles from the sun, known as the solar wind, and dangerous cosmic rays from deep space. Without it, our atmosphere would be stripped away, and the surface would be bombarded with deadly radiation, making life impossible. But here's where it gets interesting. This field isn't static. The poles are constantly wandering. In fact, the magnetic North Pole is currently migrating from Canada towards Siberia at a surprisingly brisk pace of about 55 kilometers per year. This movement is a normal part of the dynamo's behavior. However, sometimes, this wandering escalates into a full-blown reversal. Imagine a compass needle spinning wildly, unable to find north. That's a small taste of what happens during a reversal. The entire magnetic field weakens significantly. It becomes chaotic and complex, with multiple north and south poles popping up all over the globe, and eventually reorganizes itself in the opposite direction. How do we know this has happened before? The evidence is locked in rocks. When volcanic lava cools, tiny magnetic minerals within it act like microscopic compasses, aligning themselves with the Earth's magnetic field at that moment. Once the rock solidifies, this magnetic record is frozen in place. By studying layers of ancient rock all over the world, geologists have created a timeline of magnetic reversals stretching back hundreds of millions of years. It's like a barcode scanner for Earth's history. This rock record tells us that reversals are a regular, albeit unpredictable, feature of our planet. They don't happen on a fixed schedule. Sometimes millions of years pass between flips, other times just tens of thousands. The last full reversal, known as the Brunhus-Matuyama reversal, happened about 780,000 years ago. This means we're technically overdue for another one, considering the long-term average. The process itself isn't instantaneous. It's not like a light switch flipping off and on. The geological record suggests a full reversal can take thousands of years to complete, from the initial weakening to the final re-establishment of a stable, reversed field. During this transition period, the magnetic field's strength could drop to as little as 10% of its current power. This is the part that has scientists and engineers concerned. A weaker shield means more solar and cosmic radiation will reach the Earth's surface. So, what are the potential consequences? First, let's talk about our technology. Our modern world is built on a foundation of electronics, and this is where we are most vulnerable. A weakened magnetic field would allow powerful solar storms, which are eruptions of energy from the sun, to have a much greater impact. These storms can induce massive electrical currents in long conductors, like our power grids. The result could be widespread blackouts, damaging transformers, and potentially taking months or even years to fully repair. Satellites, which are crucial for GPS, communication, weather forecasting, and financial transactions, are also at extreme risk. They operate outside the thickest part of our atmosphere and are constantly bombarded by radiation. Increased radiation levels could fry their sensitive electronics, turning billions of dollars of infrastructure into space junk. Imagine a world without GPS, without reliable international communication, without the internet as we know it. That's the potential technological fallout of a magnetic reversal. What about life on Earth? The good news is that the fossil record shows no evidence of mass extinctions directly caused by previous magnetic reversals. Life has weathered these events many times before. While direct radiation at the surface would increase, our atmosphere still provides a substantial layer of protection. The increase in radiation would be comparable to living at a higher altitude or getting a few extra medical X-rays a year. It's not ideal, and it could lead to slightly higher rates of certain cancers over long periods, but it's unlikely to be a catastrophic, life-ending event for humanity as a whole. However, some animals might have a tough time. Many species, including birds, sea turtles, and bees, use the magnetic field for navigation during their long migrations. A chaotic and weak magnetic field would be like taking away their internal compass. They might get lost, struggle to find breeding grounds or food sources, which could certainly impact their populations. It's an area of active research, and we're still learning how adaptable these creatures would be to such a dramatic change in their environment. So, are we on the brink of a reversal right now? The signs are intriguing, but the answer is not definitive. We know the field has been weakening. Measurements over the last 200 years show a decline of about 10 to 15%. We also have the rapid movement of the magnetic North Pole, and there's a particularly strange area called the South Atlantic Anomaly. It is a vast region, stretching from South America to Africa, where the magnetic field is already exceptionally weak. Satellites passing through this anomaly are more prone to glitches and data errors because they're less protected. Some scientists think this anomaly might be a precursor to a reversal, like the first crack in a dam. But it's crucial to remember that the Earth's magnetic field is a complex and dynamic system. This weakening could just be a temporary fluctuation. The field might recover its strength without flipping. The truth is, we don't have enough data to predict its behavior with certainty. Predicting a magnetic reversal is far more difficult than predicting the weather. We're talking about geological timescales, not days or weeks. So, what should we be doing? Panic is not the answer, but preparation is. Scientists are working hard to better understand the dynamo process and improve our predictive models. Engineers are developing hardened technologies for our power grids and satellites that are more resistant to radiation and electromagnetic pulses. We need to think about building resilience into our critical infrastructure. Just as we prepare for earthquakes and hurricanes, we should also plan for large-scale space weather events. A magnetic reversal is a low-probability, high-impact event. It might not happen in our lifetimes, or even for another 1,000 years. But the changes we're seeing today are a powerful reminder of the dynamic and powerful planet we live on. The story of Earth's magnetic field is a story of constant change. It's a shield that protects us, a compass that guides life, and a force that is always in motion. By studying its past, we can better prepare for its future, ensuring that humanity and our technological civilization can weather the storm, whenever it may come. Thanks for watching. If you found this journey into our planet's core fascinating, be sure to like this video and subscribe for more deep dives into the science that shapes our world. See you next time.